Hello guys, welcome to Physics TV Global. I hope you all are doing well. Today I'm gonna explain the very important topic DC motor, which is also known as just motor. But before going to the objective of this video lesson, it's my request to you that if you didn't watch my video lesson on motor effect before, please pause or stop this video now and watch the motor effect first, as it will provide you all the basic concepts to understand well DC motor. Now just let's move towards the objective of this video lesson, mean the DC motor. I can assure you that after watching this video completely, without missing any part of it, you will be able to know well what is a DC motor, why do we need it, what are the basic parts of a DC motor, and how they work individually with the help of a detailed explanations on the whiteboard, animated video and simulated activity, and you will be also able to know how to draw its diagram, because as concerned exam, not only its working, its parts are very important. At the same time, you must know, you must have a good practice that how to draw a sketch diagram of a DC motor. So pay attention and let's move towards the whiteboard. Dear students, DC motor, what it is? Very simple. You know that what means of DC? Direct current. Direct current. You can say unidirectional current. This is the DC. So DC motor, it means any motors what? Which do motions, mechanical work. So it means that the device where we used what? DC current to get the mechanical work, to get the kinetic energy, that is the DC motor. Look at this diagram. See, what is this? DC supply, direct current. Why? That's due to symbol, and also the polarity is there, plus and the minus. The direction are fixed, they're unidirectional. And here, what is this? The key switch. So when we turn on the switch, what will be happen? Current will start to flow. As current start to flow, then after all the mechanism we will discuss one by one ahead. What will be happen? This will start to rotate. How? At 360-degree. There will be rotations. So this rotation is what? Due to that here we are using the current, and current because this is the energy, so electric potential energy or the electric energy or the current, the electric energy is going to convert towards the kinetic energy. Electric energy, or you can say electric potential energy, is going to convert where? Mechanical energy. We can say mechanical, or also we can say to the kinetic energy. Kinetic energy. Kinetic energy, Ke, or also we write subscript K, E capital, K subscript. So kinetic energy. So this is the DC motor. So how now we can describe? I think now you can describe by yourself that what is a DC motor. So this is a device. It is a device. Which device? Electrical device. It is the electrical device. What it is doing? Which convert electrical energy into mechanical energy or kinetic energy. One thing you can use at one time. It's up to you. That what? So what is the definition? Proper definition. How you will describe it? That it is the electrical machine which convert electrical energy into kinetic energy. called DC motor or just simple motor. Alright, now I will explain one by one the function of each part, and we will reach from current to the mechanical work, the kinetic energy, how it is possible. Very important part. So first thing here, the first part, what we need, the first component, the device what we need for that machine, that are the pair of magnets. You can see here the pair of magnets, north and the south pole. These are the board magnets, different magnets also we can use. So what is the function of these magnets? Here you can see that we know the direction of the magnetic field lines is from north towards south. So it will provide what? The function of the pair of magnets. It can be the different shape of magnets. It depends on the situation. It depends on the diagram what we are considering. So here, but mostly we consider the block diagrams where we consider the bar magnets. So the same thing you also can draw like this, because here to draw the diagram is very important. A sketch diagram how you can draw same north pole, south, and then you can show the magnetic field lines between them. Must show the direction. So it means what is the function of this pair of magnets? The first part of that electrical machine, that it produce magnetic field lines, where or you can say it produce the lines of the cloud of lines of forces between the two bar magnets. Mean what the space we have between this all space, it is surrounded. It is going to surround with what? With the help of the forces, with the lines of a forces, as here it is shown, north to south. All right, the first part. Second part is what that we need for that electrical machine, mean the motor or the DC motor, that is a coil. We also use the word coil. Sometimes we also use the word rotor, and sometimes we also use the word armature. It depends. If it is given in the question, whatever they're using the word, use the same one. And if in the question, the language, in the question language, they're using the word armature, then you use armature, don't use rotor or the coil. But if they're using the rotor, then don't use the word armature or the coil, but use a rotor. Okay? But if they're not mentioning, then it's up to you. You can say coil, you can say rotor, you can say armature. So look over here, which is armature? Before I show you, these are the magnets, pair of magnets, north to south. Here we are the magnetic field lines from north to south. Then we'll take the conductor, the specific the shape like a coil, like this. This is the one wire. Just I'm going to turn the wire in such a way, conducting wire, to make a one rotor or coil, like this red one. Okay, so this is a coil or rotor or armature. Look over here in this diagram. What is the function of this? That with the help of different mechanism, the procedures which we now will do step by step, what will be happens, you will see at the end of this lesson. You will be able to understand that what will be happen. This coil, it will rotate at 360. It can rotate clockwise direction, or it can rotate anti-clockwise. It depends on the polarity of the current or the magnets. That also we'll discuss in the next step. So here just keep in mind what the function, the second part of our electrical motor, that is a coil, rotor, armature. And what is its function? That it rotates, or it moves, circulate, or produce motion. Which motion? Circulatory motion. Okay, so we can say that what is a coil or the armature, that this is the part of electrical device or the machine or the DC motor which rotate, and when it will rotates, it will produce a motion. Which type of energy will get? We will get the kinetic energy. Okay, it means that it has very important task, important job to put that it is doing the main function, because the function, the task of the motor is to provide the kinetic energy, and this part of the machine is doing that job. So it's a very important part that is giving us kinetic or the mechanical energy. How? That you will see later. Okay, go ahead. And next we see another very important part of what? Of a electric motor. What is that? Look here, let me draw first, because in the exam usually you also need to draw the diagram, sketch diagram by yourself. Sometimes you have to draw the complete diagram of the motor. Sometimes they miss some parts of the some parts, and that you have to complete. Okay, so all right, pair of magnets inside. When you consider the coil, let me take different ink. Coil, conducting wire. Okay, then that we discussed before. Now we're talking about the commutator. So here this coil has the two ends. With the one end here we connect one connecting point at this curve shape, and another part in this side, commutator. So because they are like a both are like a ring. And which rings? Split ring, because if this is a circle, if we cut it two into two pieces, what will happen? We will get the two split rings, means one ring has split it into the two parts. That's why it is also called split rings. Keep in mind, it's very important. Usually they ask in the exam, what? Split rings. Because one ring is going to be split into the two parts. One is connected to the one end of a coil, and the other is connected to the other end of a coil. Why it is connected? Okay, that I will explain you. Now just go ahead. What is the function of the commutator? That you will see now ahead. After this, which part we have? Here, the same diagram. I will show you another part. That is what? That is the brushes. Okay, these are connected. Well, one is connected over here, one is connected over here, but they are the movable. These ends are movables. Okay, means when this coil will rotate, they will rotate and they can change the side. What will be happen? I will discuss now later. But just now keep in mind that's what's happening. I mean, this if this is the one split ring, one part of a commutator, and this is the one. This is the main end of a coil. So what will be happen when it will rotate? It will also rotate to come over here, come over here, come over here, here, and also it will come in the space at one stage. Same thing will happen in the opposite side. Okay, what will happen if the here end was coming over here, then it comes over here at this place, at this place, at this place. When this coil will rotate at this place, and one at one stage it will comes at the center. It means that so what will happen, that during the motion, that's one side. For example, this side is side S1, this is S2. Okay, of what? Of the coil. So when it rotate S1, when it comes over here, then S1 can connect to the this second commutator, and S2 will come over here. After this it will be connected to the another commutator. Means that side can be changed. How this I will explain you now later. Just here, I'm just giving you the basic concept that yes, what are the commutator, that is the commutator, what they are doing, that the end point of the router, it going to move, slide inside it. When it will be moved, it will slides. This I will also show you with the help of, explain you with the help of animated video and simulated activity also, where all your confusions, all your doubts will be clear. It's 100% sure. Okay, but just now again I'm telling you what is the commutator. Commutator are giving the connecting point or the slider connecting point. Don't say just connect, because they are not fixed. They are not fixed, they are movable. As I explained you before, was movable, that if it was here before, okay, like this, and so it came here, and it reached over here. Okay, on the other side, what's happened, that it was moving before. Suppose it was over here, it reached when they're moving, reached over here connecting point, reached at that point, reached at that point, reached at that point, and reached over here this connecting point. I mean, where? In the empty space, in the empty space. Okay, so this is the commutator. Here is just I'm telling one aspect of the one, you can say one use of the commutator. The basic use I will tell you later. So what is the use over here? That this provide the sliding contact point of the endpoints of a router. All right, after this, after the commutator, what we have? Supply. We supply DC supply. Here we also can say, here we can provide the proper diagram. Will be what? You have to show it here practically. This diagram is incomplete, so the exam purpose you have to show like this. Okay, so positive is here DC, and so it means what? The another part of the electrical motor, that is the DC motor, DC power supply. We can put here the cell, we can put here the, we can provide here the battery, or we can provide here the power supply. It depends. Like this is the one cell. For the power supply, we use this sign. Okay, plus and the minus sign for the power supply. And for the battery, that we go inside the cells, then it gives us the symbol, standard symbol for a battery. Okay, go ahead. Then now we have, I told you that what, how many parts we have discussed. What are the pair of magnets? Then there's a coil, rotating coil. Then there is a the commutator, and after the commutator, here we also can say one thing is just after the just going to attach to the commutator. I mean, these are the commutator. Okay, so on the both side, both split rings, here we'll place the brush, the carbon brush, or the just brush. Why we say carbon brush usually? Because it has a conducting material. Why? Because this give a smooth connecting point, the connection of the current to what? To the commutator. Okay, like this over here, connecting over here from the supply, from here it's positive, suppose this is the negative. So it means that this side of the commutator is what? It is negative. This side of the commutator, this is what? This is the plus. So keep in mind that the both split rings have the fixed supply. It depends on how we have connected it. Like in this diagram, what is that? This one in the left side, this commutator have supply positive, and this commutator has supply negative. The same thing is over here in this diagram. If you see this commutator, which supply it has a plus positive. Which supply this commutator has a negative. Keep this thing in the mind, and it will be very helpful to understand the further uh, work of a DC motor. Okay, go ahead. Now let's just say that how it will work. So the working of a DC motor. So all this diagram I have explained before. Okay, now we'll see it's working. So regarding to the working, first thing, just look over here, the diagram, north, south, magnetic field lines. Okay, all right. Then I am going to draw the coil. So this is one side. Suppose okay, I will change the color also. The, this is the same. This is the same conducting wire, but just I'm taking the different color for the explanation. Okay, and here, let's say over here, and it just comes down, and it will connect over here. Suppose of course here we also change the color. Suppose here's a black. This what is this? Commutator, and it is good. Right now it is at that positions. All right, in the same way from the other side. Here on the commutator connected over here. Suppose it is at that time. Okay, suppose it is over here, this point in this position, for example, and we know that what's over here. Okay, I need the same color, the black one, carbon brush, And here what we have, also the carbon brush. Look over here, this I'm going to draw this piece of commutator, this carbon brush attached with it, as I have discussed before. Commutator brush, same thing over here. But why negative the different colors? Just to represent the polarity value. Okay, now it is going to connect where with the battery. Here suppose positive, and on the other side this is going to connect with a negative. Negative positive. It means now we can say that the black, what black? Black split ring or commutator. Split ring, it is what? It is negatively. Here we're providing negative supply and it's fixed through the brush. What is doing brush? The function of the brush function of brush is that it provides the smooth connecting point, connection between the power supply and the battery, the cell, and the to the coil through the commutator. Okay, so this is the connection like this coming over here, here, and like this is moving towards the coil. Same thing with the red. What is a red? Red here is a red split ring. Red split ring is what? This is positively. Keep in mind now that what this is negatively, this is a positively. It means if this is positively, what will be happen over here? Here current will be in the upward direction, conventional current. And here what it will be happens, this time it is the downward direction. Okay, so this is the green. Here it was flow is here the downward, current is I is flowing downwards. But here if we say with the red, current is direction is upward. All right, now what will be happen? Listen carefully. Now first thing we need to see that's what happenings over here after the direction of the current, fixed direction of current. These things I can show over here, that here direction is in this diagram. Here current is upward, here current is downward, here is the horizontal also like this coming back and it going away here and here. Okay, so now look this in the diagram, that if I now I will use it later. Now see what's happening. One magnetic field is existing between due to the bar magnets, between the bar magnets, this one. Okay, and we know that because now when we provide the current is passing through the conductor, as I have explained well with the help of animated video in the motor effect lesson. There I showed you what happens, that around it also magnetic field produced at each and every point magnetic field is producing. So it means that what's happening, that the interaction of the two magnetic field lines, one magnetic field lines are due to the bar magnets and one magnetic field lines around a current carrying conductor, which can be clockwise and anti-clockwise, depends on the direction, which we can find with the help of right-hander rule. Okay, so if there are two interaction between the two magnetic fields, what will be happen? Force will act where? On the electromagnet, that conductor through which current is flowing, it will experience a force. So now how we can get to know the direction of the force? That rather in this side, the red side, the force will be in the upward direction or the downward direction. And what about this green side? Here the force, the direction of force will be downward or it will be upward. This we need to see. How we can find? With the help of Fleming left-hand rule, which I also have explained well in the previous video of the motor effect. So if now we see, but now here just with a quick review, we know that, and this is a tip for you, that if the north is in this direction, in the left side, uh, and the right side is the south, then always if the current is flowing upward, you will, when you will apply the left hand rule, you will see the force, it will act in the downward direction, just opposite. All right, so here current is flowing upward and here current is flowing downward. If downward, force will be upward. Why? Because current is downward. Same thing happens that if here we have south, here we have north, north is pole is over here, south is where other things all are same, the polarity is same, then what will be happen? Now it will be opposite. Why that? If the current is upward, the I is upward, so force will be also upward. If current is downward, I is downward, so force on the coil it will be also downward, mean the same. So again, listen, this is the tip for you. It will always happen that if you take the arrangement such a way, rather you are going to draw, rather it is given to you. If the north is towards the positive polarity, south is towards the negative polarity, then what happens? If current is flowing upward, force will be downward when we will apply Fleming's left hand rule. I will show you also in the animated video. And also I have also explained in the previous lesson of a motor effect. So here current upward, force downward. Here the direction of current is downwards. So what will be the direction? The direction of the force? It will be upward. It means what will be the motion? Anti-clockwise. Look over here. If it's moving upward, if downward, so what will happen? Motion will be like this, anti-clockwise. But if oppositely, if let's suppose that I'm taking south over here and north over here, then what will be happen? Here if current is flowing upward, force will be upward. Here current is downward, so force will be downward. It will be the direction. What will the direction of motion? Then like this. It will be the clockwise. So keep this difference in your mind well, that how these rotations can happen, and if the what should be the arrangement of the north and south, and the arrangement of the polarity of the battery, then what will be the effect on the rotation according to the Fleming's left hand rule. All right, now come to the keeping this concept in the mind, and just listen another important the facts. Here I told you before that this the green side where current is flowing downward direction, and the red side the current is in the upward direction. Now here we have discussed that force will be experienced on the coil. So what will be happen? According to this arrangement, this side mean the green side, it will move like this, anti-clockwise. So green side will move upward, this will goes downward. That's why anti-clockwise directions it will start to move anti-clockwise. Who? The rotor. Why? Due to the mutual interaction of the two magnetic field lines. All right, so what will be happen? So after rotations, this green line, this green side of a coil, it will reach at that place, here at that place, and this red it will reach after the rotation in this side. Okay, now as side has changed, before we observed, before what was that in the red side, in the red side of the coil, the current was upward. Okay, and in the green side the current was in the downward direction, but now the side has changed. The right side had reached into the left side, and the right side had reached to the left, and the left reached to the right side. Now what will be happen? Current can be opposite. Okay, that now in the green side, because what will can happens, green side it is downward, so here should be the downward. And in the right side, we know, we have discussed before, that is upward. So if red is in this side, it should be upward. But this cannot happen in this way. The rotations cannot be happen. This I will explain you in the animated video. Okay, so it means that what we must need, that if the red side here in the current of flow is in upward direction, if green side is reached in this side, in the left side, here also current should be in the upward direction even before it was in the downward, when it was in the right side. Okay, and the same thing when the red reach on the opposite side in the right directions. So here before what it was in the upward direction, but we don't want the upward direction. Okay, we need that here also the current should be in the downward direction. Then what do you have to do? It means that this commutator, we know that this is the negative, this is the positive. So there's no any problem, no any confusion, that rather when this green or reached in that side, because here the supply is same, also it means here it will be also in the direction of the current will be also same. because it is fixed with the commutator. So due to commutator, the direction will remains opposite even the side has changed. Same thing happens over here, that when this the red side has reached over here, the red was in upward direction, but when red reached in this side, because this is fixed due to the commutator, that here the direction of current was downward due to this negative polarity. So what will be happen in the same way, when this the red part will reach over here, it will be the what the direction will be the downward, not the upward as it was before. Why? Due to the commutator, due to the commutator. Okay, just listen one thing once again, then I will conclude this concept. It's a very important concept, what I am going to explain. But I am sure that when I will explain this with the help of a animated video, your all confusions will be removed. Okay, all right. So this is the supply positive negative, right? Same what we have discussed. I took the same one, the same arrangement. Okay, so now here we know that suppose this is side AB. All right, current is upward. This is side CD. Current is downward according to that polarity. Here I will say AB. What? The direction of the current in the AB is what? Upward, and the direction of CD is what? The downward according to that polarity. But when it will rotate, it rotates, what will be happen, that this AB side it will comes in here, and AB will reach over there here, and CD will comes at that place. They will be opposite. Side will be changed, side will be changed, but the directions of current will be remain same. Mean now what will be happen, the direction in the CD, it will be also the upward direction. What will be the direction in the AB side, it will be also in the downward direction. Mean rather again in the opposite side, if become this AB, this become CD. So what the direction, also here upward, also here downwards. It means that what the thing, the concept I need to keep in mind, that rather the direction of the coil is changing when it is rotating, the direction of the coil is changing, but the direction of the current it remains same, it remains constant. Why? Due to this commutator, due to this commutator. So my dear friends, this is the main function. Usually in the exam they ask that what is the function of the commutator, or the split ring, that it change the direction of current. Why it change the direction of current? Because first suppose in the right side of the coil, the current was upward. After the turn, when this right side reached to the left side, okay, what happens when it reaches an opposite side? Like same, this is here current is upward, when this here is downwards. When this side reached over here, what will happen? So it will change due to the commutator, and it will not remains upward, it will be the here, it will be the downward. And the same thing when this side will reach over there, so it's this side current was having downward, but when reach on that side, direction will be upward, mean the direction of current will be changed. So this is the function of a commutator. So if there's a little means a doubt, because it is this little complications, so it will be clear 100% in the animated video, so don't miss any part of it. So here just I'm going to conclude now, that what is the function of a commutator, that the commutator keep changing the direction of current in the both side of a rotor, commutator or armature during the rotation. All right, after that, so now one thing is just remaining. What will be happen, that when it's rotating, this side comes over here. Now if it is anti-clockwise, this side will comes over here, and this side comes over here, mean in the empty space. These corner point, as I have told you before, that they are slidable. These ends are slidable, sliding inside the commutator. This end point of the other end point of the commutator sliding over in that commutator, depends on the direction of rotation. So because it's anti-clockwise, so this will be move and comes over here, and this will move and comes over here. So in this position, what will the positions when this the coil will be in the vertical positions? Let's come this here vertically. This one the vertical positions. What will be happen? Both connecting point they will comes in the space. If they will come in the space, then it means there will be no flow in the rotor in the armature. If no flow in the armature, there will be no magnetic field around it. So then if there is no magnetic field around it, there will be no mutual interaction of the two magnetic field lines. It means there will be no the force will be not experienced, not exerted, not act on the coil due to the mutual interaction of the magnetic fields. But we observe it continue to move. So what happens? This question usually they ask in the exam, that in the vertical position, what happens when it is disconnected? When coil is disconnected from what? From the supply. Okay. So why do it continue to rotate? If one there are no mutual interaction with the magnetic fields. So why? That is due to law of inertia are due to first law of motion, because any object which is in the motion condition, it tries to continue. So as in this vertical position, it will little it will continue to move. Then what will be happen? This sides it will comes when it's coming here, moving reaches the empty space. Then after that, due to law of inertia, it will move little further, and it will going to connect with the second one, the opposite commutator. Same thing happen with this one, and this one, this moving in vertical motion, it will disconnect, and after a few moments, just after a few moments, due to law of inertia, it will connect to this one. So in this same way, the both the end points of the commutator, they will change the commutator. In this way, what will be happen? The sides will be changed, but the direction of current will be not changed. Why? Due to the commutator. And that's why it will continue to move, and it will succeed to produce the rotation at 360 degree angles. It means I can say that in this way we will succeed to convert this electrical energy into the mechanical energy after producing the rotation at 360 degree. All right, now I think it is the time. Maybe little you have some confusions, so this is the time to go towards the animated video where I will explain you all this what happens, that how it works very easily, and I am sure that your all doubts will be clear there. So watch carefully the video, pay attention, watch carefully guys. Here I gonna explain the function of a commutator and all the quick review of all the working of a DC motor. Look over here, I'm going to change the polarity. So what happens? Due to same poles, it starts to rotate. Again, when change the polarity, again it starts to move. When we again change the polarity of current, poles of magnet change and it starts to rotate. So this thing will be continue and it will continue to move. So now this is an electromagnet. If we do this function, this rotation, changing of polarity with the help of any device, then easily we can rotate what the electromagnet we have over here. So same thing we are going to do with what? With a commutator. Because we know that we have discussed before that with the help of commutator we can change the direction of flow of current. So as the direction will be changed, what will be happen in the coil? The poles, direction of the poles will be changed, and as a result, due to the mutual interaction of the two magnetic field, it will continue to move. Go ahead and just have a quick review of all of the working. See the basic construction. The armature, a rotor, a coil are connected with the commutator between the bar magnets. Here one thing is important to keep in mind, that what I have explained on the whiteboard, there I have considered north pole over here and south pole in the right side. And there we discussed then, if north is here and south is here, then the direction of the force or direction of the motion of the coil of this conductor or measure, it will be what? Just opposite to the flow of current. But here the arrangement is totally different. Well, I have discussed on the whiteboard. Here what? The north pole is in the right side and south is in the left side. That's why what will be happen? The direction of the force will be also reversed, will be opposite. Mean if here the direction of current is upward, this conventional current moving in the upward direction. So what will be happen? Force will be also here upward. And when here horizontally, what will when there will be horizontal direction of the flow of current? There will be no motion. Why? Because here the direction of magnetic field lines and the direction of flow of current are parallel. Angle between them is zero. So no force will act on the armature. Again here, when it will be perpendicular direction of motion of current and direction of magnetic field lines, then again force will exert on it. And what will be the direction of the force? According to the Fleming's left hand rule, or I gave you the tip before that if north is in this direction, then the same direction the force will be exerted. Meaning here the force will be in the downward direction. So if here force upward, current upward, force upward. Here current downward, force downward. Here same thing like here upward, that horizontally, no force over here, no force over here. So what will be happen now? Which type of motions will happens in the coil? Here upward, here downward, in the same direction of flow of current. So it will move in the clockwise. Just watch. Flow of current, here flow of current upward, so direction of force is also upward. And the opposite side, the current is downward, direction of force is also downward. So what will be happen? It should move clockwise. Here upward, here downward, so it should move clockwise. Just watch, see. So what's happening? That now when it change the direction, this left should come on the right side and the right will come on the left side, but the supply, the direction of current, it will remain same due to the commutator. So this was a function of a commutator, that it changed the direction of current in the commutator. Mean this side, if it is upward, when this side will come in this directions, the direction of current will be changed, it will be in the downward direction. Why? Who is responsible? This commutator. So again, very important point for this lesson. The direction, the function of the commutator is what? That it change, it reverse the direction of flow of current during the rotation. When the coil or the armature, the rotor is going to change the side, left to right or right to left. Go ahead. In this way, it will succeed to make a complete rotation at 360-degree angle, and in this way this electrical energy, it will be converted easily from electric energy to the mechanical energy or the kinetic energy. Okay, now just it is the time for the recapitulation. So for the recapitulation, first thing should be the definition. It's very simple. Now you can make definition by yourself, that it is the electrical machine which convert electrical energy into the mechanical energy. When we see its parts, it has what? It has the pair of bar of magnets which produce magnetic field lines. It also contains the coil armature, also called the rotor, whose function is to rotate and make the produce generate the kinetic energy. It has the commutator, pair of split rings. That function, what is the function of the split rings? What? That it change the direction of flow of current when the coil is going to change the direction from left to right or right to left, depends on the rotation direction, which depends on the polarity of the supply. the power supply, cell, battery, whatever we are going to provide it. But if we change the direction of the poles of a magnet, then what will be happen? The direction of motion also will be changed. But if we don't change the direction of the poles of magnet, but we change the polarity of the current, again direction of the rotations will be reversed. But if we change both the pole of a magnets from north to south, and we change the direction of the polarity also at the same time. So if we change both poles of magnets, polarity of the electric current, then what will be happen? Nothing will be happen. The rotations will continue in the same direction. If it was before clockwise, it will remain clockwise. If it was anti-clockwise, it will remain anti-clockwise. Notes of this topic I will mention in the descriptions below. Thanks for watching. Please subscribe my channel if you didn't subscribe it yet. Take care. See you in the next video.